So if we go from an entire radical into a mixed radical, now it's time to work backwards and go from a mixed radical, which is this, back into an entire radical. So how do you do that? Remember, this was that representative that we took out earlier that was once a pair. Now, how do I know it was a pair? Look at the index. The index is square root. That's the index. It's a square root. So you know that this guy was actually a pair. And remember, this was what was left behind. So check this out. 3 times 3 is 9. 9 times 2 is 18. So this is actually the same as the square root of 18. If you don't believe me, bring up your calculator. If you bring up your calculator, let's go back to the original. We got 3 root 2 and square root of 18. Okay, square root of 18. Boom. 3 second square root 2. Boom. Tells you they're exactly the same. Is there an easier way to remember this? Absolutely there is. Because remember, if you look back at this question here, you know and I know the index was 2. Well, look at that. If you look just at the index, this tells you 3 squared. 3 squared. There you go. That's how you get the number. Look again. Here's the index. Again, 2. So obviously, this is going to be 4 squared. 4 squared is 16. 4 squared, 16 times 3, right? Figure it out. 16 times 3, 48. This is the square root of 48. There's your original number. Okay? Watch even a third time here. Check this out. The index is 3 now. So guess what? That's 2 cubed. 2 times 2 times 2, when the original number was 4. 2 times 2, right, times 2 is 8. That's 8. 8 times 4, 32. This is the cubed root of 32. See how it works? Let's keep on going. Does it get any more complicated than that? No. It's nice and easy, straightforward. Look, there it is, power of 4. So this is minus, now remember, this is 2 to the power of minus 4. This is not minus 2 to the power of 4. Very, very important to be able to see the difference between these two things. So leave the minus 2 up front. 2 to the power of 4 is 1, 2, 3, 4, and there's your root 3, which was the original number. 2 times 2, 4, 2 times 2, 4, and guess what? You got 16 times 3 again, and 16 times 3, very simple, works out to be 48. So this works out to be 48, but how do we put this entire thing? Don't forget, we had a negative up front. Well, this is negative. This is to the 4th root of 48. That's how you would write it. Beautiful. Let's keep on going. Here we go. 2 cubed, 2 times 2 times 2, and original number inside was 4. 2 times 2 times 2 is 8. 8 times 4, this works out to be the cubed root of 32. And I know I'm right because guess what? That's a duplicate question. Oh well. Okay, here we go. Let's look at this one. This tells you want the cube of 1/3. So this is 1/3 times 1/3 times 1/3, and then don't forget to multiply this by 9. Oh my goodness, that's going to be just awful, isn't it? Not really, because if you actually multiply this out, 3 times 3 is 9, times 3 is 27. This is 1/27th times 9. Well, wait a second. Isn't that 9 over 1? Can't you use cancellation law and say 9 goes into itself once and into 27 3 times? So guess what? That's 1/3 is your answer. So this actually, if you think about it, is, well, I went too far. This is actually the cubed root of what this whole thing works out to be, which is 1/3. Isn't that interesting? That's a lot of fun. I like this kind of question. Working backwards is easy now, isn't it?